Okay, guys, so this is going to be our videos over series. So I'm going to try and break it down into 2 or 3 shorter videos, depending on how fast this one goes. So what I've done is I've attached a chart of all your tests that we use for series. You got your test for divergence, geometric series, p-series, alternating series, integral test, ratio test, root test, limit comparison, and direct comparison, all that good stuff, and all the criteria for it. So you need to make sure you know how to use this chart. I will also attach a chart that isn't blurry. I just had to size it down so it could fit on a piece of paper, but it's readable. Okay. So what we're going to do is we're going to work through these problems, and we're going to use the appropriate test. So on this one, first one, we're going to use ratio test because it deals with factorials. So ratio test says that we're going to do the limit as n goes to infinity of a sub n plus 1 over a sub n. Okay, so we're going to put an n plus 1 everywhere there's an n. So it's going to be 2 to the n plus 1 all over n plus 1 factorial. And then when we divide, we're going to multiply by the reciprocal. Okay, and then what we did after that was we split it apart. Then when we split this factorial up, we get n plus 1 times n factorial. We strip out that term. We're going to cancel our 2 to the n's. We're going to cancel our n factorials. Okay, so if I take the limit as this goes to infinity, 2 over n plus 1, that goes to 0. And the criteria for ratio test is it has to be less than 1 to converge. So it converges. And when we talk about convergence with ratio test, it's going to be absolute convergence. Okay, this one, we have an alternating series. So when we have alternating series, we need to make sure that we identify the b sub n. So your b sub n is going to be 1 over square root of n squared plus 1. Okay, it's decreasing because it's bottom heavy. And we do the limit as n goes to infinity of b sub n, and that equals to 0. So since it's bottom heavy, so this is going to be convergent by alternating series test. On your AP exam, make sure you write alternating series test, not just AST. Okay, now when we have a -1 to the n term, when we do that, we have something called conditional convergence. We have to test for an absolute convergence. Only when we do negatives, negatives involved. So if I take the absolute value of a sub n, that gets rid of that. So I get the series of 1 over square root of n squared plus 1. And I have to determine if it's going to be convergent or divergent. Okay, so this is going to be a comparison test, probably a limit comparison test. For most of these, it works out pretty good. So your a sub n is square root of n squared plus 1 on the bottom. Your b sub n is what we're comparing it to, so it's going to compare to 1 over n. Okay? Square root of n squared gives you the n, so that's what we're going to compare it to. Now, we know that the series of b sub n diverges by p-series test, because your p is less than 1, okay, less than or equal to 1. Now, limit comparison test says that we're going to do the limit as n goes to infinity of a sub n over b sub n. So it's going to be 1 over square root of n squared plus 1 times, we're going to multiply by the reciprocal of that. When I take this limit, it's going to be the same power top and bottom, so it's going to be equal to 1. As long as it comes out to be something some sort of value that's greater than 1. Let me double check. As long as the limit is greater than 0, it converges. It does whatever B sub n does. So, therefore, series of A sub n also diverges by limit comparison test. Okay? So, since one of these converges and this one diverges, this is going to be conditionally convergent. Okay, and we're going to go over conditional and absolute convergence in just a second, probably in another video, but I'm just letting you know that's how we do it. Okay, the next one, we're going to have a comparison test with this, probably a limit comparison test. So your A sub n is n over n squared minus n. Your B sub n, we're going to take the top power and the bottom power, we're going to reduce it, okay? So it's going to be 1 over n. Okay? Now, we know that the summation, the series of B sub n, it's going to diverge by a P series. Okay? So we're going to do the same thing we did in the last problem. Limit as n goes to infinity of A sub n over B sub n. So your A sub n is n over n squared minus n times reciprocal. Okay, and that limit's going to go to 1, which is greater than 0. Therefore, the series A sub n also diverges by limit comparison test. Okay, the next few are a little bit easier, so. Okay, this one, test for divergence. Okay, so if I take the limit as n goes to infinity of n over 4n plus 1, I get 1/4. If the limit does not come out to be 0, it diverges by test for divergence. Okay, so you might see them say the nth term test, that's the same thing. Okay, this one. This is going to be a root test because everything's raised to a n power or a k power in this case. So what we're going to do is we're going to do the limit as n goes to infinity. Sorry, we're doing k's. K goes to infinity of the kth root of this. So what happens is this cancels this, and we're left with that. Now, our limit as we go to infinity of this is going to be 1/3. It's less than 1, therefore convergent by root test. Okay, this one, you can use integral test or you can use a comparison test. This is something that's fairly easy to integrate, so it's up to you. So I would use a limit comparison test or a direct comparison test. So we know that our A sub n is 1 over square root of n minus 4. Your B sub n is 1 over square root of n. Okay, so we're going to do the limit as n goes to infinity of A sub n over B sub n. So it's going to be 1 over square root of n minus 4 times square root of n over 1. And that's what I get. They're the same power top and bottom. So we'll divide the leading coefficients, which would be 1. Okay, and since 1 is greater than 0, it's going to follow what B sub n does. So B sub n is going to diverge by p-series test. Because square root of n is to the 1/2 power. And if your p isn't greater than 1, then it's going to diverge. So that means the series a sub n also diverges by limit comparison test. Yep. Next page. Okay, so I'm going to do my limit as k goes to infinity of this thing. Okay, so remember that if I take the limit and it doesn't equal to 0, it's going to diverge by p-series test. Okay, so it's a pretty easy one. Okay, the next two questions are going to deal with geometric series. So let's take a second and focus on geometric series. So geometric series, remember, takes this form, okay, to where we write our terms like that, where your r is what it's multiplied every single time. So in order to get your r, we divide this term by this term. Okay, so it's -5/4 divided by 5. And so your r comes out to be a -1/4. Okay, remember that if the absolute value of your r is less than 1, it converges. Okay, so if I want to write a geometric series for this, your first term's 5, and your r is -1/4 to the n minus 1. Okay, now if it says, so we know it converges, absolute value of r is less than 1. Okay, and then if I want to find the sum, your sum formula is a over 1 minus r. So your first term's 5 over 1 minus a -1/4. And so you should come out to get 4 for that. Now, just a reminder that if I'm doing a geometric series, it has two forms. It could be to the, if it starts at 1, it has to be to the n minus 1 power. If it starts at 0, it has to be to the n power. So you'll see that on your homework. So you might have to strip out a term. Okay. This one, we're going to write both of these in a geometric series format, because 1 to the n power is going to be 1, okay, no matter what. So we're just going to combine everything, and we're going to split it up. Okay, now looking at our geometric series, we can say that r is less than 1, r is less than 1. So it's going to converge. Now I want to find the sum. So what we're going to do is we're going to do two individual sums for this. Your first term is going to be 1 over 1 minus 1/2, which is 2. And I'm going to do the same thing over here. 1 over 1 minus 1/3 should come out to be 3/2. Okay, and I'm just going to add them both together. So I'm going to do 2 plus 3/2, so it should be 7/2 is my sum. Okay, so that's just a quick review of series, your series test. We're going to be doing a lot of series stuff because I can guarantee you that this is going to be on your AP exam. So the next video we'll look at absolute convergence, conditional convergence, which we've already talked about, and power series and radius convergence. Okay, hopefully you have a good evening, and thanks.